all are safe, and welcome back to my channel YoungTutor. And today I bring up to you a brand new chapter of physics called as motion. So this chapter we all have been doing since we were in grade 6, but the level is increasing day by day or grade by grade. So let's start with the chapter motion. So first of all, what I'm going to discuss, the first topic which we are going to discuss is what is force. What is basically meant by force? Force is basically nothing but it is a push or a pull. Push or a pull in a particular direction. Why am I saying in a particular direction is because let's take an example. For example, this is a box. And there are two people standing on either side of the box. Here we've got the second person and we've got two people standing. So the person 1 is applying a force, a push force over the box, whereas the other person is applying a pull force over the box. So the direction which comes out to be, so I can say that the net direction which comes out from both of them is this side. Yes, is this side, because one is applying a push over in this side, whereas another is applying a pull in this side. So for example, this is if this person is having a force of 3 Newton and if this person is having a force of 1 Newton, so the net force becomes 1 Newton plus 3 Newton, which comes out to be 4 Newton, So that's why the term in a particular direction is very, very important, and we have to be quite specific in these things. Like you can see that there is this person who is applying force to the box, force to the cart in this direction so that it could move forward. Okay, so next we have are the effects of force. What are the effects of force? मतलब कि जब एक फोर्स लग जाती है किसी भी ऑब्जेक्ट के ऊपर तो उस फोर्स के क्या आउटकम्स हो सकते हैं, और यू कैन राइट what could be the outcomes of the force or what could be the after effects of force. So the first is direction, the second is speed, the third is state, and the fourth is shape. So a force can change the direction of an object. For example, if you are playing football, you applied a force on this ball and changed its direction from east to north. You changed its direction from east to north. And how was this change of direction possible? This change of direction was possible because of force. Then we have the change in the speed. When you kick this ball hard, its speed will increase. Or if you don't kick this ball and you just leave it, after some point of time the ball will stop, or either the speed of the ball will start decreasing. This is also because of force, and this is because of a force, contact force, referred as the frictional force. This is a grade 8 concept. Then we have that a force can change the state of motion. Means from rest to bring it can bring to motion, or from motion it can bring an object to rest. Now the question is that how is these change of states even possible? This is all possible because of force. For example, a ball is in a state of rest here, and when a force applied to that ball starts moving. So that means from a state of rest it came to a state of motion. But whereas if I say that the ball was in motion and someone came and stopped the ball, so we can say that the ball from motion came into the state of rest. So we can see the change in the states as well. The change in the states as well. Now we come to the shape. How can a shape of an object change? Using force. For example, if you are playing with the clay dough, how do you change the direction? How do you change the shape of this clay? When you apply some force on it. Yes, when we apply some force on it, and because of that force applied, because of this force applied, this clay dough changed its shape from either circle to a rectangle or any XYZ shape. Okay, so these are the four effects, four things which a force can do. Moving on next. Then we have motion. About which we are going to talk about. Now, what do I mean by motion? Motion is when an object changes its position. When an object changes its position with respect to time or a reference point is called as motion. Now, what do I mean by a reference point? For example, in this image which you can see, if this tree becomes our reference point, so you can say that the bus is moving forward with respect to the tree, because it is leaving the tree behind, and your bus is continually moving in one particular direction. It is leaving behind the tree, it is leaving behind the reference point. A reference point is a point through which we can conclude a particular position of the object. Okay, so this tree became our reference point, which helped us in concluding the direction or the position of the bus, and it has to be to respect to time. For example, at time 0, at 0 seconds, the bus was in a state of rest, but whereas at 6 seconds the bus came into motion. So this means that time also plays a very crucial role. So the two things which plays an important role is, number one is your time, then it is your reference point. Okay, moving forward. Then we come to the state of rest. We talked about motion. We have already talked about motion. Now let's talk about the state of rest. The state of rest. When an object does not change its position with respect to time. For example, if I draw a tree over here again. So if this bus is standing here, with respect to the time, and with respect to our reference point, if it is not changing its position with respect to the time as well as reference point, then we can say that the bus is in a state of rest. Because neither it is changing its position with respect to the time or with respect to the reference point. So these were the two states of motion. Or let me draw a flow chart. We can categorize the states of motion is in motion or in rest. Okay, so this was a briefing. Now we have four important parts regarding which we have to talk about in this chapter. First is distance, second is displacement, third is speed, and fourth is velocity. These are the four main core concepts of this chapter, motion. So these topics are to be extremely important and are to be understood. Okay. So the first topic which I bring up to you is distance. What do I mean by a distance? Distance is the total path, or I can say the total length. Total path or the total length covered by an object. For example, if I say this is the bus and the bus is moving in a straight direction in a rectilinear motion, and it is covering a distance of, it started from this position and it came to this position, and it is traveling a distance of 1 kilometers. Okay, it is traveling a length of 1 kilometer. So this length or this path, comes out to be our distance, okay. This length or path comes out to be our distance. So basically, what is distance? Distance is nothing but it is just the total path or the total length covered by an object. Now let's talk about displacement. What do I mean by displacement? Displacement is the shortest path covered by an object. It is the shortest path covered by an object. For example, if I say that there is a person who started at point A, and took half of a round and came to point B. It took a circular round from point A, it came to point B. Now if we need to find the displacement. What is the displacement? It is the shortest path covered by an object. So the object is basically covering this much path. Yes, it is covering this much path. This is an indirect way. What could be the direct way of covering to the path? The direct way could be this. Yes, this line. Wait, let me draw it with red. This line is the direct path. This is equals to this because this is the same path. It started from point A and it is coming to point B. Just this, that it is an indirect way. It is an indirect way of coming to your position, whereas the displacement is the direct, or it is the shortest way of coming to any position. It was indirect or a longer way, whereas the displacement is the shortest distance. So we can say that if I take this as a numerical, give me a second. Yeah, so if I take this as a numerical, so, and if we need to find for half of a round, what is the distance and what is the displacement? The distance becomes, we know the circumference, which is 2 pi r, but it only took half of a round, so we can divide it by 2, which becomes pi r. Pi is 22 by 7 multiplied by 7, which comes out to be 22 meters. This is the distance, and the displacement comes out to be 7 into 2, 2r, or diameter, because this is the displacement covered by the object. So I hope so that this is clear. And what is 2r or d? It is 14 meters. So 14 meters is our displacement, whereas 22 meters is our distance, and this was our displacement. Moving on to the next topic, we have speed. What do I mean by speed? We all are studying this from a very smaller grade. Speed is nothing but speed is the distance upon time. It is the distance traveled upon the time taken. And the SI unit of speed is meter per second. So if I want to say that a person traveled 500 meters in 5 seconds, and I have to find the speed. What is the speed? The speed is distance upon time. It is 500 upon 5, which will come out to be 100 meter per second. That means it is covering 100 meters in 1 second. We can also write this as this, or 100 meter second raised to the power minus 1. This is the other method of writing this. Okay, next we have average speed. Average speed is the total distance divided by the total time taken. The total time taken. For example, if I am not covering this path, if I say that if this is my home, if this is my home and this is my school, and if I am going from home to school in different sections, this is, for example, 3 meters, this is 5 meter, and this is 6 meter, and I'm dividing my way, and I'm going with different time, and I'm going through with different time. For example, in 3 meters I took 3 seconds, in 5 meters I took 4 seconds, and at 6 meters I took 10 seconds. Okay, and in 6 meters I took 10 seconds. So what will be my average speed? The formula of average speed says, total distance upon total time taken. The total distance comes out to be 3 plus 5 plus 6 meter upon 3 plus 5 plus 10 seconds, which is 6 plus 5, 11, 11 plus 3, 14, 14 upon 5 plus 3, 8, 8 plus 10, 18, 18, it could be further simplified, which is 7 upon 9 meter per second, comes out to be my average speed. This is my average speed. Okay, moving on with the next slide, which is the last topic of the today's lecture, which is velocity. So first of all, we discussed about distance. We have already discussed about distance, about displacement, then about speed. Now we come up to the last topic, which is velocity, which is interrelated to all three of them. Okay, to all three of them. Velocity is displacement upon time. It is the displacement upon time. Now I'm going to tell you that how all these three of them are interconnected. So for finding out the displacement, we need to know the distance, or maybe not sometimes distance, but it matters in certain situations. And to take out the speed, we need to have the distance. And to take out the velocity, we got to have displacement. So we see that all four of them are interlinked to each other. And sometimes speed could be equal to velocity if it is moving only in a single direction. अगर एक ही direction में चल रहा है on a straight path, then your speed could be equals to velocity. But if it is turning back, or if it is in a circular motion, then the situations are different. So I hope so. So thank you so much for watching my video till here. If you did like my video, don't forget to like, share and subscribe to my channel Young Tutor, and click the bell icon so that you are the first ones to get notified for my each and every video. And I hope so that the concepts which we have discussed in the today's class is all clear to each one of you. Thank you so much.